Hey there, YouTubers! Hello there, Dr. Sheep here. Welcome back to another science video. Science is back, baby! Woo! 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 I can't do that too loud because I'm in an apartment now. Plus, every time I do it, my voice just dies. It's also the first video, not just our first science video in a while, it's also our first video in the new space. Let me know what you think. It's certainly not perfect, but it'll have to do, I guess, for the time being. Sorry about the glares. I really don't have a solution for those. But, oh well. Anyways, I mean, speaking of science videos, we did do that egg video where we dropped them onto some pork. And we also did some economics. But today we're going to do some more classical science. We're going to be talking about astronomy. No, though, right? Because, like, that seems to be all I'm interested in these days. Anyways, we're going to talk about the Bortle Scale, as you can tell by the sign behind me and by the title of the video, because you're not illiterate, right? Right? First, we'll get into what it is, then how it works, followed by some visual representations, and finally, how to use it. Because if you don't use it, you lose it. Imagine if you used it and you lost it. What am I saying? The Bortle Scale is a 9-level scale used to quantifiably measure how much light pollution there is in the night sky. Basically, it's like if I had a bunch of squares, okay? Alright, and each square had a shade of black in it, okay? I can't really do that with an expo marker, but you get to see the picture, okay? And let's say this is darker than this one. So I'm going to give it a 10, but this one is darker than that one, so I'm going to give it a 9. And this is an 8, but we're basing this off of, say, I don't know, number of black particles per, like, square inch or whatever, okay? So the more black particles you have in the square, the larger the number. That's what the Bortle Scale does, except with photons of light in your night sky. Anyways, kind of, sort of. However, each scale is often described in words and not by the scientific units. That's because the scientific units are like magnitude per squared arc seconds. Whatever that even means. I don't even know what that means. Okay? Of course, I'm not a scientist, so. Another unit for measuring the Bortle Scale are NELMs, naked eye limiting magnitude. It's crucial that we use the human eye because it gives us a fairly hard limit on what can be seen. Although you should never use the human eye as a reference for anything, unless you can quantifiably give it a measurement. Anyways, this is important because, well, let's chew on this. Chew, chew, chew your cud just like a cow. Moo, 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 moo. I'm going insane, aren't I? The lens of the eye is only so big, and the sensor, or the optic nerve, is only so big. The optic nerve can also only be so sensitive that your brain would have to work overtime to remove noise. Noise refers to fluctuations in light that makes an image grainy, and this grain takes away from the image as a total, unless, of course, you want film grain, but that's a whole other day. Not to mention, the brain wants things to move relatively slowly. It has your eyes refreshed 30 to 60 times per second. At the high end, that's 1/60th of a second of light exposure. That's not much. Especially in the terms of astrophotography. Now let's look at a camera. A camera could, in theory, have a sensor as big as you want and a lens as big as you want. Camera sensors' sensitivity can also be adjusted to ridiculously sensitive proportions. It can also take an exposure for as long as you want with the use of a tripod to keep it steady during the exposure. However, if we're taking pictures of stars, for example, the stars have perceived motion because the Earth is rotating, causing them to move in the sky. This leads to arcs of light forming behind stars in your image. Now, once in a while, some people, including myself, want one of those images of the star's arcs forming on the image. Most don't, and will buy a mount that can track the stars, eliminating those artifacts. All this is just to say that the human eye, for all of its faults, it provides a good base compared to any camera, because, well, there's just so many different things you could adjust with a camera, and not everybody's going to be able to agree on it. Sorry, sometimes I can really geek out about cameras and the eye. Let's just move back to our topic, the Bortle Scale. You know, I just got these glasses out of my pocket because I was going to use them in the previous clip in some bit, but the bit wasn't written into the script. It was just something I was going to do, and then I forgot to do it, so now I'm just going to wear them. John E. Bortle, the creator of the Bortle Scale, is an amateur astronomer who published the scale in Sky and Telescope magazine in February of 2001. What a year, right? Now, granted, if just anyone posted in this magazine, this article probably wouldn't make a lot of headway. Simple enough. However, John Bortle was very active in the astronomy space in the 90s. Space. And 2001 came shortly after the 90s. So, he made over 200,000 variable star observations and had made thousands of observations on over 300 comets. Wow. Not gonna lie, that makes you a pretty big deal. Now, Bortle is not perfect, nor is his scale. It has received a lot of criticism. Phil and I are a part of that said criticism. I mean, just depending on the altitude, the humidity, and in our experience, smoke in the atmosphere, or any other pollution for that matter, class 1s, the lowest class, having the least amount of light pollution, can look very different from one another. Not to mention every other class, from 1 to 9. I mean, just take the images and the experience of Phil, Kyle, and I's trip to a class 1 September of 2001 as an example. It can't be perfect. Oh, goody goody, my favorite part of every video, the rant. When we went, it was very humid, but there's nothing I can do about it. Nebraska is just humid all year round. Now I see why my teacher got rid of this thing. That, and he liked PowerPoints. I mean, just look what Nebraska is. We're just above the 40th parallel. We're in the middle of a continent, and there's mountains here, mountains here. So all this moist air comes from the Gulf Coast and makes us humid. What am I supposed to do? Plus, there's a jet stream that runs right here. And that just keeps the humid air from going further north. And it just sits there. Plus, Wyoming, right here, was on fire at the time. You know, just up in blazes. I mean, I couldn't smell the smoke like I could during the California fires of 2020, but I could certainly see it. You like that I could just reference a map now? Pretty cool, right? This all becomes more apparent in my images of the galactic center. Close to the horizon, the stars and the dust of the center were red. And as you move to the top of the image, the stars and the dust become blue. This suggests that something was scattering the light more effectively than the atmosphere was. The night the images were taken, when I looked overhead, without a question, we were in a class 1. However, based off descriptions, the horizon told a different story. This all supports the idea that the scale has flaws, specifically the descriptions. Now, the science says one thing, i.e. the light pollution index numbers. That's not a real thing, but if it was, you get my point. But my eyes and Phil's eyes and Kyle's eyes say another. Again, these weren't good conditions, but it helps emphasize the errors. God, that's cool. Okay, with all that stuff out of the way, let's focus on how the scale works. It is a measurement of light pollution, as I stated earlier. 1 denotes essentially no light pollution, and 9 represents a sky that has been saturated with artificial light. Each of these classes are denoted by a range of artificial light measurements. Each class going from 1 to 9 shows progressively less and less stars. Now, when I wrote this, I was hoping this section would have more to talk about before just moving to the visual aids. In hindsight, this was a feeble attempt, and I might as well move to the visual aids, which I'm going to do. I'm moving. See? I'm moving. And now I'm moving back because the internet is a letdown. That's all I have to say. I was online looking for images to talk next to in this next section, and I couldn't find anything. What I did find is a computer graphic, I guess. Internet. You know what? I'm not even going to bother trying to write internet because I am illiterate. What am I supposed to do, right? Anyways, the computer graphic, it shows progressively less and less stars and kind of what the sky looks like as you get more and more artificial light. I'm just going to use it and talk alongside it for the next section. So I'm just going to point this out now. I think I've gotten pretty good at reading a teleprompter. Okay, I'm going to read the class, followed by numeric values, descriptions, and my own personal comments. Class 9 is the worst possible light level. It has a rating of 4 nelms and is less than 18.28 apparent magnitude per arc second squared. Or squared arc seconds. Whatever, I'm not going to continue to read it like that. I'm just going to read it as mag per arc second squared. It's easier and faster, and I don't care. The only objects visible are the moon, brighter planets, and the brightest star clusters. One such cluster is a personal favorite of mine, and that's the Pleiades. The cluster is the only Miser object visible in this class. Miser objects are a collection of objects in the northern hemisphere that are relatively easy to look at. They're numbered 1 through 100, and each one is designated by M something. So there's that. Interesting thing about a class 9, the town I live in, according to certain sources, doesn't actually have a class 9. And the only spot in Nebraska, according to some sources, is a small area in Omaha. So go Nebraska for not having that much star light pollution. However, some will argue all of these, and that's because the lines are very blurry. It's as if you have 2100 vision and you forgot your glasses. Class 8 is between 4.1 and 4.5 nelms, and mag per arc second reading is the same as Class 9. Some constellations may be barely visible. Miser objects 31 and 44 are more visible in the best conditions, but will require a more experienced observer that I am not. The same can be said about the visible constellations. Class 7 is where things really start to improve for stargazing. It is classified by having 4.6 to 5 nelms and 18.38 to 18.94 mags per arc second squared. The sky is a light gray, and M31 and M44 can be looked at more clearly with a telescope but lack detail. Other Miser objects are fuzzy ghosts of their true selves in telescopes. The difference between Class 7 and 6 are tough, but there are some clear differences. One of which is M33, which is still not visible, but M31 becomes more visible. Class 6 ranges from 5.1 to 5.5 nelms, and is 18.84 to 19.5 mags per arc second squared. Class 5, in my opinion, is where stargazing becomes feasible. At Class 6, you can do it. I do it from my balcony of my apartment. However, I'm looking in a direction where it's much darker, So it's kind of a strange class 6. Phil and Kyle's parents' house is a true class 5, and I would say that this is a comfortable darkness level for stargazing. Everything darker than that is just better, so. At this level, in my opinion, the stars of the Milky Way, the arm of the Milky Way, become visible, and you can clearly track where it is in the sky. Class 5 is also how bright it is at night during full moons and other bright phases. If you're already in a very dark sky, kind of like Class 1 or 2. Anyway, Class 5 ranges from 5.6 to 6 nLMs and 19.5 to 20.49 magnitude per arcsecond squared. As Phil and I have talked about, there's a good reason why you go to dark areas during new moons, because the moon is just that dang bright. It can bring you from a 1 to a 5, and a 5 is like the threshold for good stargazing. So I have a deep history with Class 4. I have seen it more times than anything else. I would like to say I will see it more times than anything else, but I've moved into the city since then, so. My parents' house is the reason why. It's smack dab in the middle of the range for Class 4, which is 6.1 to 6.5 nLMs and 20.49 to 21.69 nice magnitude per arcsecond squared. I hope I said Class 4 earlier. I had no idea until I started looking into the Bortle Scale and other places with light pollution how spoiled I am. In the continental United States, the East Coast has horrendous light pollution. And from what I've heard, astronomers in that area will drive hours just to see a Class 4. Now I just have to drive 15 minutes. Or as a kid, I just walked outside. I remember how upset I was by how much light pollution there was. Of course I wish there was still less, but now I am humbled by the fact that I live so close to a darker spot. Either way, the Milky Way arm is clearly there. It's mainly just a large collection of dim stars, however. Class 3 is a big difference, in my opinion, compared to Class 4. It wasn't until recently that I got the chance to visit one. And it was, and still is, awesome. Class 4 is good for people wanting to get out of the city, but if you can get to a Class 3, go. Alright? The dust in the arms of the Milky Way becomes visible. Now, it's more of a haze that seems distracting if you're used to a Class 4 and higher like I am, and is kind of awesome once you realize what you're actually looking at. The sky becomes littered with stars, and fainter constellations start to become washed out, interestingly enough. Class 3 ranges from 6.6 to 7 nLMs and 21.69 to 21.89 magnitude per arcsecond squared. I have yet to see a Class 2, so my description is not from personal experience and will be short. Class 2 ranges from 7.1 to 7.5 nLMs and 21.89 to 21.99 magnitude per arcsecond squared. Astronomers say this is a true dark spot. The Milky Way becomes magnificent, and many minor objects are visible to the naked eye. However, faintly on the horizon there is still some light pollution, but it's negligible. Finally, we have arrived at Class 1, the darkest the sky can possibly get. This is the exact reason why Phil, Kyle, and I drove 5 hours, not to see a pipe in the ground, but to look straight up. Let me tell you this, it was worth it, and it's awesome. I think every human should have the opportunity to see the sky as our ancestors did just only 150 years ago. Everything is visible. By definition, there should be no light pollution. The Milky Way, even on the horizon, is stunning. You can see some definition in the dust, too. Dark patches on the arm become visible and striking. There are so many stars, it can feel overwhelming trying to pick out constellations. The descriptions are off, though, in my opinion. Except for one. Except for one. Jupiter is annoyingly bright. If you look at it long enough, it kind of wrecks your night vision. That's personal experience here. It's true. One last thing about Class 1. Actually, two last things. One is I forgot to input the NELM and MAG rating. So, insert here, editor me. It's probably on my face right now. Thank you. Another thing. I have to tell you because if you're planning to go see Class 1, do and don't get your hopes up. When you look at a picture of the Milky Way, a lot of people say about pictures of just anything that the picture never does its justice. In this case, it actually does the opposite. The picture is better. That's because it's a long exposure and it can collect more light than your eyes can. And you can feel let down. Phil and Kyle and I kind of did. But the longer we thought about it, we became thankful and humbled that we had the chance to even see a Class 1. There have been, are, and will be people who will never get to see a sky like that. Phil and Kyle and I, we're truly blessed that we had the disposable income and the means and a place close enough that we could just drive there in a day. It's interesting to think that humanity, up until 150 years ago, on every clear moonless night, got an unimpeded view of the cosmos. I'm jealous of them, to an extent. Disease is clearly bad, but I just can't wait to see another Class 1. Well, that's all, folks, for this video. But don't click off. Obviously, there's still the outro and watch time. Please. While writing this video, I realized that some people have no idea what the frick I'm talking about or what to look for if they ever make it to a Class 1. And so, specifically when I say Milky Way arm, if you've lived in a city your entire life, you're like, huh? And you're like, I'm interested. I want to get into this. I want to drive outside the city and see these things. But I don't know what I'm looking at. Well, in 2 weeks, I'm making a video all about the vernacular. It's probably already up. Depending on who's seeing this, just because, well, most people see my videos after they're up. Anyways, been up for a long time. So anyways, just stay tuned. I'm going to go over the vernacular, and I'm going to just go over what to look for in the night sky when you're in a Class 1. So stay tuned, because there's going to be plenty of astronomy videos coming your way. 2020 was chemistry, 2021 was physics and chemistry, physics and astronomy, and 2022 looks like it will start with a lot of astronomy. But anyways, I would like to thank you all for watching. Please like, comment, share, and subscribe. Resources in the description. You can go look and see where the nearest dark spots are to you. I have those linked. Please like, comment, share, and subscribe. New videos every other Friday, 11 a.m. Central Time, and good night. Subs for trees, subs for trees, subs for trees, subs for trees. Oh, you're still here? I thought I told you to go home. Oh, you want more? I'm flattered. Check out the playlist. If you want exclusive content, check out my Instagram, Dr_sheep_YouTube. That's all lowercase. If you want to help the Earth, subscribe. When I reach 100 subscribers, I'm going to plant 10 trees. If you feel that's too small, then check out my channel where I lay out even bigger goals. Finally, stick around for the next 20 seconds to give me that sweet watch time. Bye!